All right, everybody, welcome to class 66. So, what are we doing today? Looks like we got like a class lab activity thing going on here. We were using a PhET simulation in class. If you weren't there for class, just check it out. It's pretty easy to use once you get used to it. But the first thing we were doing was just kind of checking out what happens when waves meet. And one really important takeaway here, is kind of thinking about, let's go green today. I was thinking about what happens when waves come together and after they come together. So, for example, let's say this wave is going to the right, this little wave here is going to the left. When those two waves, what happens is they come together and they make one real big wave. And after they come together, a lot of people think that the waves bounce off each other. That's actually not what happens. They actually pass right through each other. So they actually kind of switch places. So we have the little wave here and the big wave here. And they go on, the way they were going before. So that's a really important idea that not only do the waves combine when they overlap, then they go through each other. So, this part was like they're making predictions and stuff. So number 7 says, describe what happens before, during, and after the waves meet. So the important thing is that during, the waves combine. And then the after, they pass through each other. Okay, they do not bounce off each other. So when two waves come together and make a bigger wave, we call that constructive interference. So the next one was a little bit different. We had one wave that was like a positive upward wave and another one that was like kind of like a negative wave, and they were coming at each other. We noticed that actually when they come together, they kind of cancel each other out. You get like this flat nothing wave. And afterward, just like before, they go through each other. So they kind of switch positions again. So this one goes down, this one goes up. Okay, and they go back the way they were originally coming from. So it asks about your prediction. So what happens before, during, and after? So again, during. They combine or cancel each other out, however you want to say it. And then after, they pass through. They do not bounce off each other at all. All right, this is known as destructive interference. So a couple other things we checked out. This one asks you to send a wave, look at a green dot, what happens. So describe the motion of the green dot as it passes through. So the green dot actually only moves up and down. Now, why does that make that a transverse wave? Well, the wave is moving to the right. So we'll say the wave moves right. A little semicolon in there. Moves right. Okay. And the particles move up and down. So the direction of the wave and the direction of the particles on the wave are perpendicular to one another. Therefore, it's a transverse wave. Okay, I'm not going to write all that down, but hopefully you're listening. This is why waves transmit energy and not matter. As the wave moves to the right, the particles only move up and down. So the particles aren't really moving with the wave. The wave propagates energy, it moves energy through the particles. And describe the difference between a wave hitting a loose boundary and a fixed boundary. So a fixed boundary, we would have realized that the wave flips. And a loose boundary, wave does not flip. So here we have some different images of different kinds of interference. You'll notice destructive here is the left column. Okay, it's this column here. You notice the waves approach, come together, they cancel each other out, and then they pass through each other like nothing ever happened. Constructive waves, waves coming together, they make one big wave in the middle, and then they go through each other. And then different amplitudes, we're not really going to focus on this a lot as far as naming it goes. It's kind of like a destructive-ish interference. Some people say partially destructive. You notice the waves don't fully cancel each other out, but they do make like a baby wave there in the middle. So what we call this in physics is superposition. So superposition is basically when two waves overlap, they can add, cancel out, or form a new wave altogether. So the third one we saw there, third column, was an example of like a whole new wave, not necessarily adding or canceling. And this is known as interference, which can be destructive or constructive. After the two waves pass through one another, there's no evidence that they ever interfered. So let's look at these different examples here. So in this first picture here, this is an example of destructive interference. All right, the new amplitude here, actually, those waves would cancel each other out perfectly, so the new amplitude would be 0. These two waves, let's see, they definitely make a bigger wave, so that's going to be constructive. Okay, and let's see, 2, 2, so we're going to get, or 1, so it's going to be 3, a +3 amplitude. And then the last, some people call this partially destructive. There's different ways to say so, partially destructive, P, D. And the amplitude would be like -1, it would be like -1 downward. So one really important idea, again, is that interference is used to describe standing waves. Basically what happens is the person or the thing generating the standing wave sends a wave, or a stream of waves, if you will. Those waves are constantly reflected back. Now, the person or the object that's creating the standing wave keeps sending waves, and those waves keep interfering constructively and destructively with the reflected waves. Okay, so constructive interference takes place at the antinodes where you see a big wave. Destructive interference takes place at the nodes. Now, when we have constructive interference at the antinodes, all right, those are in phase. When we have the destructive interference at the nodes, okay, the incident and reflected waves are 180 degrees out, fix that, out of phase. All right, we're going to go with the red now. So here's how I like to add waves. So, you have the two waves lined up here. This first wave is going to have an amplitude of +2. This one's going to have an amplitude of +1. Okay, so how do I translate that exactly to, the picture on the right? So I just kind of count over, let's see, it looks like we're 2 boxes over. So I'm going to count over 2 boxes here and put a little dot at +3. Okay, because +2 +1 gives you +3. So here we have -2 and -1, which gives you -3. So how many boxes over that? 1, 2, 3, 4, 5, 6. So I'm going to count over 6 boxes. 1, 2, 3, 4, 5, 6. And I'm going to go down to -3 right about there. All right, again, we have +2 and +1. I'm going to count from the right. So 2 boxes over from the right, 2 boxes over from the right, and it looks like we're going to be about here. If I mark off my ending point for the wave and my beginning point for the wave, we can just kind of fill in here. All right, that was pretty ugly. Let's do that over again. I'm just going to make it kind of like a triangle. Okay, not ideal. You usually want to do it with like 1 pen stroke, but just so you guys can see it, I'll draw it something like that. Actually, I wonder if I can make these thicker. Let's see. Oh, there we go. Oh, that's nice. All right. Let's use some of that. So I can kind of go like this. Oh, there we go. All right, that's good stuff. Maybe a little too thick. We'll go down like a notch. Okay. All right, next one here. So actually I went to change thickness now again. That's kind of annoying. Okay, so we look, let's see, we have +2, -1, so that's going to give us +1, right? So I'm going to count, let's see, so it's going to be +1. It's going to be like right there. Mark one beginning point, so let's see, we have -2, +1, so we have -1, so that's going to be like over another 4 boxes over, 1, 2, 3, 4, and it's going to be right here. And let's see, we have +2, -1, so that one's going to be right here. Okay, we'll just +1 up there. All right, so now make this just a little bit thicker. All right, we'll mark these off real nice. So let's see, we have, start here. All right, that looks way better. All right, this last part, we're going to talk more and more about this, but just understand that when a wave strikes a boundary between two mediums, some of the wave is transmitted and some is reflected. Nope, that's not how you spell reflected. All right, we see some examples there. This picture on the left here, you'll notice it shows a wave hitting a boundary, reflects, and you see how it hits a fixed end and it flips. This other one here, you see it's changing medium from one rope to another, one spring to another, and notice how some of it reflects, some of it transmits. Check that out. Since it hit a loose end, it didn't flip, it just went backwards, but it's still an upwards wave. Okay, just like we had spoken about earlier.